Hello everyone, this is Wit, and in this video we're going to introduce this topic of Lewis dot structures. Here are my 4 rules or steps of doing a correct Lewis dot structure. Essentially what a Lewis dot structure is the structure and the blueprint of where all the valence electrons are in a molecule and how they connect atoms to each other covalently. The first thing we're going to do is sum all the valence electrons in the Lewis dot structure. You use that with the periodic table and with the elements and the compound. It's sort of like when you start building a bench or some sort of project with the instruction manual. I always say that it's important to start off in knowing what we need before we really start. One of the most important rules with Lewis dot structure is that you have the right number of valence electrons. So better figure out how many valence electrons you have. But don't forget, sometimes there are extra electrons due to the ion charge if you have a polyatomic ion. Next, we start off with our skeleton structure, which involves picking a central atom, the one with the highest capability of bonding, and connect everything with single bonds. And then we start with the octet rule. We complete what we call the octets, and there are usually 3 potential outcomes to this. We're going to do an example that's pretty straightforward, nothing extra at the end. In this example, I want to talk about PCl3. Number 1, we need to sum all the valence electrons. So we have 5 from phosphorus, 7 from a chlorine, but there's 3 of them, for a total of 26 valence electrons. So what I would do in the middle of the problem is just have that 26 out there on the right. One of the 2 rules with a correct Lewis dot structure to ensure that you have a correct Lewis dot structure is correct number of valence electrons. 2 rules. If we don't have 26, this will not be correct. Number 2, we're going to start our skeleton structure. And phosphorus is the least electronegative option between these. Chlorine usually likes to bond with 1 thing. Phosphorus typically likes to bond with 3 things. I know that based off their valence electrons. And so we're going to put phosphorus in the middle and chlorine at the 3 ends. Now, if you draw something like a T shape at first, that's not that big of a deal. But important part is that we pick a central atom, connect everything with single bonds, and each bond is worth 2 electrons. If we were to really draw this or like look at it in an electron microscope, there would just be a space between these with 2 random electrons where we can't guarantee their position or their velocities, really. That gets into quantum mechanics. But for Lewis dot structures, we simply just say, let's pretend there's a straight line between the 2. We have used up 6 valence electrons up to this point. I like to keep track of it so that we make sure we always have rule number 1 correct. All right, step number 3. We're going to start completing octets. The other important rule that's usually being obeyed is something called the octet rule. Take a second. What number do you think of when you hear the word octet? It should be 8, like octopus. So, most atoms want 8 electrons associated with it, either through bonding or electrons that just belong specifically to 1 atom. Now, there are some octet exceptions. I want everybody to know that hydrogen likes to have 2 electrons associated with it. Another very common one that shows up on exams is boron. Due to its number of orbitals in its valence electron shell, can only have 6 electrons associated with it. And then when the central atom, or when you have a central atom that's on the third row or below on the periodic table, it can have 8 or more electrons due to the additional number of orbitals that it can pull on for bonding. That does not apply here. However, phosphorus is an example of something that is a central atom in the third row below. But we'll later on see that has a normal octet. So let's go back. Let me zoom out so you can see everything. Let's go back and start adding our octets by adding these double dots of electrons. They're called lone electron pairs. We just added 6 to that chlorine, so I'd say -6. 6 to that chlorine, -6. 6 to that chlorine, -6. One thing I should have put is that when you complete octets up here, I want you to start with non-central atoms. So start with your chlorines out to the outskirts first. So if you can do the math correctly, hopefully I'm trying to do it in my brain, you should have 2 valence electrons left. Now let's look at the central atom. That central atom has 6 electrons associated with it right now. So with an additional 2, it is now happy. All the octet rules are obeyed. And by keeping track of the whole time, I know that we have the correct number of valence electrons. So this is happy. Or another way of saying that, it's a legal structure. There are other situations in which we'll go into what happens when things sort of go awry, and I'll try to do that in a future video. But here, in general, is how we're going to do a Lewis dot structure. Thank you for watching this video. If you have any questions, leave a comment or reach out to us, and good luck studying.